This is Tomohiro Inoue from NTT and coordinator of the IOWN Data Hub task force, and I'd like to introduce the Data Hub. So, the IOWN Data Hub, or shortly IDH, is a new data service that integrates database, storage, and other functions required in the IOWN era applications. It is also the data management and sharing infrastructure that enables fast data processing, usage, and exchange among multiple parties or locations. It is uh, it is intended to be commonly used by other application nodes by maintaining compatibility with existing applications. So naturally, it supports multiple data access paradigms such as tables, queues, folders, and so on. Data Hub is built on top of the IOWN DCI data-centric infrastructure and can take advantage of features of OpenAPN and DCI. So we have recently published a document called the Data Hub Functional Architecture. Here is the structure of the document. First of all, the goal of the Data Hub and its expected roles and functions are explained. Next, Next, it defines the service types and classes for the Data Hub. I will explain it later. Then, we analyze the gaps in the current technologies and present Data Hub architecture to solve the gaps. It also illustrates example use cases and the next challenge. In various use cases discussed in the IOWN Global Forum, there are multiple demand patterns expected to the Data Hub. So we first organize these requirements into several service types. A service type is defined as a unit of functionality and behavior that should be implemented in the Data Hub services. Now we have 5 service types: distributed relational database, key value store, graph store, message broker, and object storage. On the other hand, it may not be sufficient to provide individual service types to realize use cases. It is necessary to design a component that implements multiple service types. Such a component is defined as the service class. We have 5 basic service classes, uh, each of which supports a corresponding service type, and 4 applied service classes. Those are converged database, context broker, virtual data lake or federated object storage, and virtual data lake house. Please check the IDH document for details. As I explained earlier, we have analyzed the gaps in existing technologies. Here are some examples. As for distributed RDB, there are performance and scalability issues. Storage access and network latency causes limited functionality in distributed environments. For message broker cannot guarantee short latency in heavy traffic and is limited in types of the data and queries it can handle. Object storage has low cost of storing data, but not for queries. Also, it only supports simple access patterns. Then this figure shows the generic structure of IOWN Data Hub reference implementation model that consists of 4 components and 3 network segments. Client is to request data to Data Hub. A front-end tier provides load balancing, query routing, protocol translations, and so on. Data service tier serves and updates data in response to data access requests from its local cache or storage tier. Storage tier stores actual data. Each tier is, of course, connected by networks in distributed environments. I will show some acceleration method used by IOWN Data Hub. Within this generic implementation model, there are various points that can become bottlenecks. One, of course, is the network that connects between the component tiers. A network constraint will result in data transfer delays and low throughput. In IDH, direct optical communication between two endpoints, two components provided by OpenAPN ensures low latency and high bandwidth connectivity as needed. Next, the connection within the data service tier becomes a bottleneck. That's slowing down complex queries to several petabytes of data across multiple servers. In IDH, high-performance cluster can be built by using the DCI architecture that allows the dynamic combination of multiple resources. In particular, protocol optimization of DCI, such as RDMA, enables the processing and management of huge amount of data in near real time. In addition, the behavior of each component itself will be improved. The amount of data, for example, the amount of data being transferred can be reduced by making each component smarter, such as by using smart NICs. So far, I have explained improvements using the generic architecture image, but the IDH document also contains more detailed reference implementation for each class. I hope that will be interested in that. You will be interested in that. And now for the last slide, IOWN era applications will need to handle data 100 times or more the amount of data than today with much lower latency. IOWN Data Hub provides high-speed and high-capacity data service infrastructure for this purpose. We will continue to develop IDH utilizing IOWN infrastructure through POCs. That concludes my explanation, but I'd like to introduce another leader of this IDH task force, Katsan. Katsan, if you have anything to add, please.
Thank you, Inoue-san. I think your explanation is great and covered all of the details, all of the elements that are included in our documents. But again, we have analyzed today's data management and data sharing technology, especially we can see around the cloud. But still, regarding the digital era realization, we have to improve the technology. Thus, we have started on our journey to develop the better data management and data sharing technology, which is well described in this document. So please have a look at this document and please join us in developing this new technology. Thank you.